Alright guys, welcome back. We're going to be solving another question from the Engineering Mechanic Dynamics from the Meriam textbook. And in here we have this card that is released from rest at the starting position A. So released from rest, which means at point A, the speed is 0 and it rolls down the incline and onto the finish line at point C. So it's going to stop at point C. And we have a constant acceleration down the incline. So from A to B, we have constant acceleration. So our acceleration is constant and it will be equal to 2.75 meter per square second. And we also know that the speed from B to C is constant, meaning our acceleration is 0. As we know, acceleration would be derivative of the speed over time, or the change in the speed over time. When we have a constant speed, the acceleration will be 0. So we need to determine the duration TAC. For this race, basically we need to figure out the time from A to B and the time from B to C, and at the end the total time TAC is going to be what the question is asking us. And the effects of the small transitions area at B can be neglected from the question. So as I said, we just have to find these two time values in here, and from A to B we have a constant acceleration. We can use our formula. So the velocity squared at point B minus v squared is basically 2 times a times the distance that this car is traveling. So from A to B, basically we have these 3 meter that we can see. So 3, and instead of acceleration, we can simply put the value that we have, 2.75 VA is equal to 0. So basically our VB squared is 2 times 2.75 times 3, and we can find velocity in here, which is basically the square root of, so our velocity would be the square root of 2 times 2.75 times 3. That's going to give us 4.06 meter per second. All right, now that we have this, we should be able to find the time. So basically the distance that the car is traveling, we can show them with S. So basically the second location, we're going to show it with SB is equal to SA plus the initial velocity, which is from point A times T plus 1/2 of acceleration times TAB. And this T is TAB. So the velocity is 0, so this will be 0. We can just put our distance, or if we just bring SA to the other side, SB minus SA will be equal to 1/2 of A times TAB squared. And we know SB minus SA is 3, so it's equal to 1/2 of the acceleration, 2.75 times TAB squared. And now we can find the time. So basically this time the square root of 3 times 2 divided by 2.75, that's going to give us 1.477 seconds. So now we figure out the TAB, and we also figure out the velocity as at B. So because from B to C our velocity is constant, which is the value that we found with VB, we can find the time in that part too. Basically this time we're going to go with the SB plus the initial velocity, this time BT, and this T is TBC plus 1/2 of A TBC squared. Because there is no acceleration, this will be 0, and SC minus SB is basically the distance that we have in here, 4 meter, is equal to, we figure out the velocity in the previous section, 4.06 times TBC, and the TBC in here will be basically 4 divided by 4.06, or 0.985 seconds. So as I mentioned, the T that we are looking for is TAB plus TBC. So our TAC is TAB plus TBC, or the value that we found here plus 1.477. And yeah, the final T that we're going to get would be 2.462 seconds. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.